Okay, can you see the DLAB07?
I can see it.
Okay, so we hope you can get the DLAB6 done. Okay. However, the way we teaching for Tech two is quite different in the past for too many years. Now I want to teach you guys really the way you will be deal when you're working in the company. Okay, so try to learn. This is really try to help you guys to isolate the problem. Okay, anything if you're not quite follow it, let me know. Okay, that sound better or lower?
The sound is good.
It's good? Okay. So
Yes, sir.
anyway, you see the schematic?
Yes.
Okay, now, how many IC on this
Five.
circuit?
5.
5.
Okay, you find. You know how, right? Depending on the U. We don't care U, A, or B, or C, doesn't matter. Just U1, U2, U3, U4, U5. Okay, basically you get 5 IC, correct? Okay, now, in general, I can telling you, this is the one we'll be learning. That's the IC 74191. If you look into the data for this IC, that will be binary counter. They can count up 0 to 15 and 0 forever, okay? Or you can counting down 15 to 0 to 15, keep going. So you're looking on first thing I'm talking about U4. If you want to calculate to make the counter count up, what can we have to do? I want to counting up. You're looking on the pins of U4, telling me what logic, whatever need
Is it the clock?
count up.
or
Yeah.
Okay.
You're counting up. That question regarding to your understanding when you're reading the schematic. Okay, again, if I want you for counting up, telling me which pin, which logic we supposed to apply.
And flying rope.
Just telling me the pin
14
and
or
the
the
logic.
14?
What pin? What pin number?
14.
14. Let's see.
For the U4?
14 is the clock, right?
Yeah.
So you need the clock. All right?
Yeah.
Okay. They're telling me you need the clock go to here. Correct? What the
Yes.
hell?
Yes.
I'm talking about counting up. Who knows? Okay, I'm telling you. What pin number 5, 4?
Determining if it's counting up or down.
Perfect. So now I want you counting up. What pin number 5 supposed to be?
Zero.
What pin number 5 supposed to be?
Check the timing diagram.
No. Okay, you can take a timing diagram. However, now just by looking into the display, telling me
Would
what
it be a clear?
logic,
Or
what logic at pin number 5 you counting up?
okay, hold on. Input. So we're looking at
Just telling me 0 or 1, right? That's what you need to get.
oh, that's fair.
If you see on pin number 5, you can see they put it way. All right?
Yes. Five.
So,
Up,
what
down.
logic on pin number 5? To go up.
1.
Who else?
Zero.
0. You get 50-50, right? If not 0, then 1. However, I'm telling you how to see. Okay? If you see right here, you see the bar over here, right?
Second low.
That means 0 will be up. They don't have any bar over. 1 will be down.
Okay.
So you want go up, you want that to be 0.
Not you?
You mean up. And the bar over mean active low. 0 up, 1 down. What else?
Low zero.
What do you mean no 0? Okay. So again, I try to repeat it. You want counting up, you need the clock go to pin 14, correct? You need the 0 at the pin number 5. However, I still need a little more. Who else
Hmm.
to make sure
You load it after
after
that, right?
what?
You load it after that. Pin 11.
No, you don't care about loading.
Oh, okay.
Right now, I just general. You want go up, you want the clock, okay. You want 0 at up and down, that be fine. Still one more. To guarantee they able to counting up. What pin and what logic? Who can tell me?
Pin 4. Logic 0.
Pin number 4. Pin number 4 already routed. Try to thinking, okay? That's what the different we want to do to help your guy, okay? Still one more. Who can tell me exactly?
Hmm.
Okay, otherwise, I tell you. You make sure load pin 11 must be
0.
logic 1.
Yeah.
Logic
Oh,
1.
sorry. Oh,
Right?
first.
The thing is when you're loading, you cannot count it. So they have to be 1. Logic 1 at pin 11. Something else, we don't care. If you get those requirements, automatically they will be counting up. If you get any question, okay, go ahead, keep telling me, okay? By the way, I will be asking you to see whoever can help me. Normally, I get a microphone connect to the USB. It's working so far so good. I don't know. Today, when I try to go to set it up, or the sound, I didn't see anymore. I don't know where they go. So that's why now I have to using the sound through my iPad. If whoever knows, let me know. I appreciate that. Okay, anyway, going back to the schematic. If you want to L4 count up, you need the clock on pin 14. You need the logic 0 at pin number 5 and make sure pin 11 load have to be logical 1. But think if you understand that, when they're not counting up, then you know how to troubleshoot it. You see that? When you troubleshooting, that means you check to make sure pin 14 you get a clock, pin 5 you get a 0, and pin 11 they must be logical 1. Okay, any question, anything up to that thing?
Mr. Pham.
Yeah,
So the little bubble on pin 11, does it change the 1 to a 0?
If you loading, you zero, right?
Yeah.
But the thing is when you counting, you cannot load it. Loading higher priority than counting. If you loading, that means pin 11 equals 0. Then input A, B, C, D go to output A, QA, QB, QC, QD, and you cannot counting anyway.
Oh, yeah. Okay. Okay.
Okay? So you want to count pin 11 must be 1. Don't want to load.
Just to answer
any-
that question. Just to answer the question, the bubbles generally are the same as inverters, so it just swaps the signal from low to high or high to low.
Yeah, that bubble that means active low. Low they do it. One they not. So that's why you see the load they get a bubble, right? That means 0, then you want to load. 1 you not loading. Okay? Now, if I want to counting down, what we supposed to set it up for U4?
Pin 5-1.
Pin 5 logic 1. Correct. You know it. That means clock still same thing. Load still same thing. Only thing is pin number 5 of U4 for counting down must be logic 1. Okay? So if you're looking into here, 0 count up. 1 count down. Okay?
Okay.
Yeah, that's perfect. Next thing, I will be ask you about U1, 1A or 1B. Okay? What is it?
Buffer.
Perfect. Buffer. Okay? Buffer means what? Input 0, output 0. Input 1, output 1. Only the difference is, I given you example. U1A, pin 2, logic 1, maybe 2.5 volt. However, the output pin number 3, still the logic 1. However, they bring it up to about 4 volts. You understand 4 still logic 1. Okay? However, they want 5 volts. Okay? Standard logic 1. So, buffer means 0 in, 0 out, 1 in, 1 out. However, output will be bring it up to the standard logic. Okay? However, if you want input pin 2, same as the output pin 3, then pin number 1 here, enable, must be 0. Okay? If they're not 0, output and input isolated. Okay? They're not same logic. So that is why you understand when you measure U4 pin 14 for the clock, okay, if you not see the clock, then you can take U1A pin 2. If pin 2 you get the clock, pin 3 you not get the clock, then you have to pay attention on pin number 1. Pin number 1 must be 0. That's why we're talking about troubleshooting. So now you know U1A or U1B, okay? How they working. And the same, U5, U5A, U5B. Same buffer, okay? U5A. Input pin 2, output 18, okay? And so on. They will be the same logic if pin number 1 routed, okay? That's just a buffer. So pin number 1 routed. So they go this way, okay? 2 to 18, 4 to 16, and so on. Okay?
Yeah.
And that will be happen same 5B, controlled by pin 19. If pin 19 is 0, routed, then input 11 go to 9, okay, and so on. So nothing to talking about that, right? Easy. And now, last one, 74, you know, the flip flop, okay? The flip flop, you get Q equal to D if the clock going 0 to 1. If the clock go this way, when the clock going 0 to 1, Q equal to D. However, in this case, they connect not Q equal to D. Okay? What happened to this flip-flop? The flip-flop will be toggle. Okay? The flip-flop toggle. When clock going from 0 to 1. On the time. Whenever you see not Q connect back to input D. So when they get a clock, they toggle. What that mean toggle? Toggle mean if they was 0, now they go 1. If they was 1, now they go 0. Okay? If you get any question, just let me know. I prefer for you guys when you're doing the lab. Very important is wiring the circuit. I don't want any wire go across the IC. That's very, very difficult for troubleshooting. Leave IC alone. Okay? When you troubleshooting, you want to measure, for example, L4 pin 9. That means you connect the DMM high to pin 9 on the IC. Okay? On the IC. If you get the wiring across the IC, you cannot measure it. You cannot troubleshoot it. Okay? Okay, now I will be ask you a question here. If I apply 0 here, that means you get 0 here. You apply to PD1, pin 1, 0. See what happened.
Load on U40.
Okay, perfect. Yeah, you know now. So basically, you see 0 here and you get 0 here. Right?
Yeah.
That means you will be loaded. Something else. What else?
U3 clear 0.
L3 Q. That means you say 0 here, right? Correct?
Yeah.
Okay, perfect. If 0 here, they go to down and up. Now they 0, right? That means you can ready to counting up if you want counting. Okay? So up to this point, okay? We'll see. Next, this will be telling you. Okay? That's what you need to do your test program. Okay? And this is a port A, port B, port C. Okay? Now I need to go to another one. Okay, now this is timing diagram for 74 191. I hope later on you have no problem to following the timing diagram. That will be telling you the counter can be low, can be count up, can be count down, or what else. Okay. Now, if you're looking into the timing, when the load 0, then you will be loading. That means QA equal input A, same thing B and C and D. So by looking into the loading. When they load, can you tell me what logic for A, B, C, D input?
D.
Now, you see right here, A will be 1, right?
Yeah, 13.
0, 1, 1. That number 13, right?
Yeah.
Okay. So when you loading output also number 13. So when you see the load and now you're looking at the output here. Right here, 13. Okay. Then you can say number will be 1, 0, 1, 1. Number 13. Okay. And when you're looking into the output, you see number 14. That means when you want to counting, you need to the clock. Okay. One clock they count 1, 13 go 14. Okay. Now, if you're looking on this one, you want counting up, the yield must be 0. And CTEN, counting enable, must be 0. Okay. Then they will be counting up. However, if you're looking up, load must be 1. Okay. When you're reading the timing, you see they get a bar here. What that means?
We have to fill it in.
Don't
Now.
care.
Don't care. Perfect. Very good. That means they don't care whatever here. Okay? So, when they counting up, guarantee, load must be 1. Okay? And this one you don't care, then you don't care about ABCD. However, you care that you must get the clock. And also, down up must be 0. And count enable must be 0. Then they have to be counting up. That's requirement. Okay, try to learn. The thing is you have to deal with a lot of the timing. The data for each IC, interface, circuit. No one teach you. At work, you see one IC. You don't know. Go to Google. Then they given you all of the information. Okay? That you can do. Okay, now, in here, after they load number 13, they apply the clock to count, they go 14, then they go 15. Okay? We're already telling you. Counting up, they counting 0 to 15, then go back to 0. So that's why go back to 0 and they count 1, 2. Okay, they don't care. And now they're talking about countdown. However, you can see the IC get to pin output, max, minimum, and RCO. So you got see the max minimum output first, normally 0. Okay, when they go from 14 to 15, they go high, then they go low. And also output RCO, normally high. When you reach 15, they go low, then they go high. Okay? Basically, the counter, when they counting, at the end, they get the output coming out to let the people know I done. For example, I want to counting from 1 to 60. So when the counter get up to 60, they send out the pulse. That means they go high, then go low. Let the people know I am done 60 counting. That's what happened in your clock. Okay. You know, in your clock, you get a second, minute, and hour. So the first counter will be counting for a second. If they go up to 60 seconds, they send out the logic. So the next circuitry looking into that. And now they counting 1 minute. See that? And the circuitry for counting a minute, same thing. When they count 60 minutes, they send it out, the signal. So the hour see that signal, they will be counting 1. Okay? That normally happen. Okay? And we'll be talking about that later in the circuit. The thing is right now, we're doing the lab automatically. That means you don't have to do anything with your hand. Computer will be verified. Okay? If you want to do a manual, that means you have to connect output here to the oscilloscope. Then you will be see this signal or this signal. That's the manual testing. But right now, we're doing automatic test. Okay? However, we still guarantee something wrong with the max and minimum output or RCO. Then the test has to fail to let you know that output not working. Okay, any question up to counting up?
Mr. Pham,
Yeah,
what's inhibit again?
inhibit. Don't care.
Oh, okay.
That means doesn't matter 1 or 0. They don't care. So we pay nothing with those. That's what the thing do in this program. I don't care how many students, doesn't matter to me at this time. So I just like to teach you the better way, good for your guy. Okay? That means deal with the problem. Okay, now, same thing, counting down. If you're looking here, So you can see that right now counting down 1, then they count to 0. Okay, when they counting down from 15 to 0, when they reach 0, then you can see this to signal. Okay, just let the people know I already down to 0. Then they going up to 15 and so on. So counting up 0, 15, 0. Counting down 15 to 0 to 15. Okay, any question about this timing? Normally, I prefer you get around maximum 2 weeks to get a 1 lap done. Maximum 2 weeks. You can build circuitry at home. Okay, you can develop your software at home. When you come into the class to run the test, that means you deal with the problem. Up to the point when you run the test without checking any wiring yet, and you're able to find out what's wrong. That's what the purpose we want. Okay? Now, this also telling you IC and what pin, how many pin, what pin for VCC, what pin for the route, okay? What pin for A, B, C, D, Q, A, Q, B, Q, C, Q, D. If any question you want, just let me know, okay? And this is a quiz, okay? And try to do it. Right now, sometimes I don't care, so that's why I given you the answer. Try understand, and later on, we don't have that the same way. And that will be for 244, okay? Low logic, high logic. Either low or high, that means don't care. G, high impedance, right here, okay? That means when you disable, so they not connect input and output. High impedance means output, they get a very big resistance. So they're not loading any current into the IC. And that's the same for this guy. Buffer, however, only 4 IC. Okay? For get inside the IC. Okay? Now we go back to that one. Okay? That one already done. Let's see. The thing is, iPad very give me a hard time like in the desktop. the desktop, you can get Excel, anything to run. It's not on the iPad. So that's why when I download the schematic here. I download on the timing. However, when we want to talking about the program, then I cannot. Okay. Now, let's see. Okay. Now I'm using my iPad. Can you still hear me?
Yeah.
Yes.
Okay.
Yes.
So that means my iPad still have me. Okay. Now I'm talking about the program. Okay. Normally, when I upload the file, I given you the simple program. That means the first part of the program will be the same for most of the computer. You guys still try to using the old one. Okay, I don't want that. Make sure you download the one I given to you with the lab. Okay, and the test in here, 1 or 2 or 3 here. Okay, just given you one example for that one, and you have to add in more. Okay, now what I want to talking to you here again. If you want to using your computer at home, you need to include that line. Okay? However, if you run your program in the class, then you comment it out using second header here. Make sure everyone understand that. Okay? Now, when you're working on the program, remember, normally they're using the function. Okay? First thing, I get two functions. I call a test counting up or test counting down. Okay. This is a function prototype, right? That means you have to tell the compiler, I get a function prototype. However, after you get the function prototype, then you have to get a function definition. Okay, now we're looking for function definition. Okay, this is the end of the main. That is the main program here. Then after the main, now you get the function definition. That means what you want to do in that function. For now, I think you get this function I given to you. Try to get along with the function later on. You have to do by yourself. Okay? If you're looking here, I try to explain to you. System color 0D. That means I want to display in the light bubble. And this, that title, map data, pick up. Now, you want count up. Use your for statement. J0 equal to 1. Up. If J less than 16, you increment 1. Okay? You open the brace. Inside the for loop, first thing, they must be increment that number. That number plus. The thing that they run 16 tests. If you don't try to increment the test number, that means you get only one test number. Okay? So it's not right. You have to increment. Then you apply the clock, pre-clock, and you say, expect data, J. That means J equal to 1, they count to 1. J equal to 2, they count to 2. The computer can understand 2 things. They can understand the hash number. or they can understand the decimal number. Okay? Then you verify output and whatever. And that they run 16 times and for loop at it. And after that one, they want to test that one. Okay? And that will be done. When you close that, they done. Okay? For counting up. And now counting down, same thing. Only thing is, 4, j equal 14. If j greater than or equal 0, j minus, that means 14, then they go to 13, 12, keep going down to 0. Okay? And if you're looking into the port C, then you can say if at the beginning, peak up U1, U4. However, after they count down one number and the peak up, they change to U4 only. That's why they're using if statement. Okay? And count down, then now they verify that PC5 and counting down. So try to get along with the function definition. However, I see here, I can see some wrong on that one. You can see. Now, you start void here. You open. Okay? And you must be closed. So, when you start for statement, you open. Then you must be closed. So, this is the close for loop. Okay? And after that, you're adding one more test. And this is the close for that one. Okay? Whenever you open, you must be closed. Otherwise, you get the error right away. Now, in the program, you test to test number 5. Okay? Then you test for count up. Instead, you have to type in 16 test. Then you don't have to call that function. So the program will be jumped to the function definition for test counting up. Okay, and they can run. Also, after counting up, they go back to the line 96. They jump into counting down. Otherwise, you have to type in too many lines. That's not good at all. Okay? Try to get along with the function prototype function definition. The thing that we'll be using all the time for almost the rest of the digital lab for TechQ. So, any question, anything for the software? on this one. Okay? And also make sure you know the class will be end on June 7th. That means next month, the fourth week next month, last one. And we'll be off for 2.5 months. No summer 2024. Reason city have no money. So we will be returned on September.
Okay.
So up to this point, any question, anything?
No.
So you get any question, anything else, I can help you out. You see that we don't have a quiz for you. We don't have a much assignment. The thing is, if you go to the city college, you can get a lot of assignment. The thing is, they focus on theory. We did different way. They get 2 years for the AS degree. We get only 1 year. So we focus on hands-on. What can you do for technician job in the company? Okay, that's a difference. And again, I said, if you're working on your software, you get an error, you don't know how to fix it, just text to me. You want to be online. I will be helping you. Okay?
Thank you.
Just about 5 minutes, 10 minutes, 15 minutes can solve your problem. Okay? Otherwise, don't try if you don't know how you're working on that. Okay?
Okay.
Okay. You understand? In the past, they're asking for how many students must be in Tech 1 or Tech 2. Now, not. They don't care. And basically, out of my hand, I don't care either. I just teach for the student want to learn. Okay? You get anything and whatever you don't understand, just bring it up to me. I can help you out. Okay? Any more questions? Anything else?
No.
Okay, if not, then you guys will be have a good weekend, okay? And we see you on Monday.
Okay.
Okay?
It's
Yeah.
it's open tomorrow, lab.
Yeah,
Wait,
you
hold
still
on.
work. You
I have
still
I have something
Yeah,
to
go
say
ahead.
hold quick. Hold on.
Yeah.
No, we're good. Because I was thinking of the 27th, Labor Day. Yeah, never mind.
27. That's the off.
Yeah.
27 on May will be off, no class, holiday. Remember, May 27, Monday, no class.
Okay.
Okay? Anything else? If you see me, you ready on the question, let me know. I get a time. I work with you. Very good if we're talking by person to person. Okay? Guarantee you cannot be better than myself. So don't worry. Anything you don't know, just bring it up. Okay, so basically, final question on mine. Is it the sound okay for you to listen it? No noise or no, anything else, right?
Yes, the sound was good.
Good, sir.
Only in the beginning was echoey, but not after you fixed it.
Okay, so now it's okay, right?
Yes.
Okay, the thing is, on top there, I have to take one also. So I guarantee,
Okay. You should be
I have-
okay.
Yeah, thank you. I don't
Mhm.
know why microphone is not working. I couldn't understand.
Okay. Maybe
Okay.
go to the settings.
Setting.
Settings.
Yeah, I go to the setting. Okay. However, they not show up anymore
Oh.
on that device. That's a weird, really weird.
Bluetooth.
Yeah. Before I go to the sound, look output, I can see my microphone. Now
Okay.
they disappear.
Okay. Yeah, I don't know about.
Yeah.
But-
if whoever knows, let me know. Okay.
Okay. Yeah.
I have to fix that anyway.
Yeah.
Okay.
But the sound
So
was good. The sound was good with no noise.
okay. Perfect.
Mhm.
So very good night, everyone. Okay.
Good night. Yes, sir.
Good night.
Good night,
Right.
sir. Thank you.
Good night.